only mode.
Hello, everybody, and welcome to the October 25th, 2022 edition of Fire on the Fives, brought to you by the National Weather Service Fire Weather Program. Some logistics before we begin. Please ensure that you mute your phone or use the audio pin provided. Please do not put your phone on hold. If you are unable to use the pin, you can put your question in the question box and a moderator will ask a question for you. This Fire on the Fives, this and other Fire on the Fives will be posted at our National Weather Service Fire Weather YouTube channel at the address provided on the slide here, or you can do a search on YouTube for NWS Fire and Fives. Today's presentation will be about red flag warnings and a science-based methodology for red flag warning criteria. Our presenters today are Heath Hockenberry, who's the National Fire Weather Program Manager for the National Weather Service, based here at NIFC at the National Interagency Fire Center in Boise, Idaho. Dr. Patrick Marsh, Chief of Science Support at the Science Support Branch of the National Weather Service Storm Prediction Center in Norman, Oklahoma. Dr. Tim Brown, Research Professor and Director of the Western Regional Climate Center at the Desert Research Institute in Reno, Nevada. And Dr. Tamara Wall, Research Professor and Deputy Director of the Western Region Climate Center at the Desert Research Institute in Reno, Nevada. Today's topic again, red flag warnings and a new science-based methodology for identifying red flag warning criteria. Let's go ahead and start with Heath.
Well, hi, everyone. Thanks for joining today. I wanted to kick this off by saying the key question that I get a number of times, especially from regional program leadership, is where is the Weather Service going with red flag warnings? What might be the vision for the future? What can we do to improve services? Kind of a three-part question. And the only way to improve those science-based questions is through scientific research and study. So this project that you're about to hear is a response to those questions of what the requirements are and where we're going in the future. Of course, the key element within the red flags is the issue of fire behavior, which you will hear about as the study details are presented. And I think another key question is how can we buy into this? How in the world can we apply this? And are we talking about a replacement or supplementing the current decision process? So it's good to have Tim and Tamara here and Patrick to help explain some of those details, along with giving you at least the base knowledge of what this started as and what research has been completed so far. So I did want to provide that as an introduction, is that this is part of answering those key questions of where we're taking and where we'd like to take red flag warnings in the future. With that, I'll keep my remarks brief and turn it over to Patrick.
Thanks, Heath. Hopefully I will keep it short as well. I just wanted to say a few words about how this project got started. It was originally funded through the National Weather Service Science and Technology Integration Portfolio as a C-STAR project. For those who don't know, C-STAR projects are projects that are designed to transition things to operations. It's more operationally based research. Projects can be funded for anywhere from 1 to 3 years with a maximum funding level of about $150K a year. The projects are supposed to involve collaboration between operational forecasters and university scientists. And each year that a C-STAR funding award is made, the RFP, the request for proposals, actually provides guidance onto what the kind of research that STI is looking to fund. For example, these can range anywhere from fire weather research to severe thunderstorm research to numerical models to all the way over to social science. And I believe last year was a social science RFP. So that's where this work started. Based on the success of the project, the Sea-Star project actually ended last year. But the results looks promising enough that NOAA decided to use some of the disaster, the DRSA, the disaster, I forget what the acronym stands for, some of the supplemental funding to continue the work and expand it to include things like particularly dangerous situation, red flag methods, and providing guidance on distinguishing the upper echelon of red flag warning environments. And so that's what you'll see now is basically some of the preliminary work that was done as part of the Sea-Star, but we look forward to continuing that as we move forward. Additionally, there'll be, as part of the funding for this kind of work, there'll be an additional kind of a bake-off between some of the new fire danger indices that have been created, both internal to the Weather Service and through partners with the land agencies, kind of learning their strengths and weaknesses. And so that part of the project should take place in the next couple of years as these methods begin to mature, and hopefully those in attendance here will be interested in those results and offer their insights or be interested in participating in some of the verification work that is to come. So that's kind of the background of how this is funded and where we're going. And I'll stick around, and if people have questions in the future, feel free to email me at patrick.marsh@noaa.gov, or you can just ask questions in the chat, and I will be happy to try to answer those as they come up. So with that, I will turn it back over to Larry.
Thank you, Patrick. Much appreciated. And with that, we're going to jump right in, turning it over to Tim Brown, Dr. Tim Brown, and Dr. Tamara Wall from the Desert Research Institute. Take it away.
Thanks, Larry. And yes, Tamara and I will do a little bit of tag team here. Are you going to go into full PowerPoint mode there, or are you going to keep it like this?
Yeah, I can give it a try here, Tim. Just a second.
Okay.
Is that better?
That's it.
There we go.
Okay.
Okay. Yeah, thanks for that. All right. Yeah, this was the title here was the project title for the Sea-Star effort. So next slide. Larry's controlling the slides for us because we didn't have control, apparently. Just a little bit of history about red flag. It goes back at least to the early 1960s, maybe a little bit before that. The Portland, Oregon Fire Weather Office, or at that time U.S. Weather Bureau Office, put out a couple of things about this red flag, and here's what they call the Summer Student Trainee Report. And what I highlighted here, if the occasion presents itself, we will, in addition, issue a red flag warning, which warns of an extreme lightning or drying conditions or any other conditions which we believe warrants special attention. And I found this particularly interesting because even going back then, it seems like the question was arising, the role of red flag in terms of extreme fire behavior, but also this lightning piece of it, and we'll come back and we'll talk about that later. And then in the next slide, again from the Portland office in 1964, they issued a glossary of terms used in fire weather discussions, And here's the red flag section. Again, highlighting the importance in relation to fire behavior. And also, I think that last paragraph there under red flag is interesting because it says forecasters should ordinarily use red flag term only a few times each season. And this is one of the things that has come up during the course of our work, the frequency of issuances about this, and some users making references that it appears too often, and so there can be some numbness to that. So just a little bit of history there. It goes way back, and I think the next slide is the NWCG, the National Wildfire Coordinating Group, official definition in their glossary, which implies a level of fire behavior characteristics and ordinarily precludes methods of direct control action. So one or more of the following is usually involved: a high rate of spread, prolific crowning and or spotting, presence of fire whorls, and strong convection column. And so one of the things that we focused on is the high rate of spread. We felt like that was going to be the best and most consistent definition. I should also highlight that this work was done really in large part to Sarah Jacober, who was a master's level graduate student with us during the time of this project. And she was also a Forest Service firefighter and a crew boss, among other ratings in her portfolio. And so she was an excellent person to work on this because she also had a good sense of how people were looking at these out in the field on the ground and how they were interpreting and thinking about the red flag warnings. Okay, so the next slide. And Tamara, feel free to hop in here because you led this part of it early on. But one of the first things was to get a sense, well, what are the red flag warning criteria around the country? And so annual operating plans were gathered for every place. That information was coded in relation to red flag warnings. It turns out there are 524 unique criteria around the country. The phrases here on the right represent the most frequently used codes. So relative humidity, wind speed, that's pretty much common every place. But what's also listed here is other factors that different offices will use at different times. So really, other than something about humidity and wind speed, there's not been, or there isn't currently, good consistency across the country about the factors to take in. So the next slide then, we decided to focus on three things. As I mentioned, wind speed and relative humidity were common every place anyway, and that makes sense to use that because we know they're going to be related to extreme fire behavior. But what was really lacking for many places was something about the fuels conditions. There's, I suppose, a number of things that one could look at, but we felt like the National Fire Danger Rating System, since it calculates fire danger components that incorporate things about fuel dryness, that the energy release component, which is the amount of energy at the head of the flaming front, since this is very commonly available in NFDRS, it describes the fuels. It obviously has some weather component in it as well. that these should be the three things to at least initially focus on. So taking those three weather elements, yeah, Larry, you can go to the next one. The idea was, well, let's actually compare that to fire on the ground. And so at the time that we were doing this, there was a very good data set available of fire occurrence from 1999 to 2014. That data set has been updated now and is in pretty good shape to date. So how to define extreme fire behavior in the context of our problem question. And so it's decided, let's focus on the daily maximum rate of spread, that is acres per day, corresponding to each incident. And by doing that, then you have, we know that weather is more than likely going to play a big role in that. Sometimes these rates of spread can be pretty strictly terrain driven, but for the vast majority of time, right, there's going to be weather elements that are playing a big role in that. And so the wind and the humidity, and then also now the ERC, that energy release component. So then on the next slide, after doing a number of statistical analyses, the process was, let's look at percentiles and that were associated with the maximum rate of spread. And for each percentile ranking, we will assign it a score from 0 to 5, 5 being the higher percentiles, or in the case of RH, a lower percentile. And scores of 4 and 5, 80th percentile on above, seem to be highly related to this maximum rate of spread. And I'll show you a little bit more about that here in the next slide. Which is, and by the way, we did this for all of CONUS. I'll show you a few examples here. These charts include Arizona, California, Colorado, Florida, Minnesota, Montana, North Carolina, Oklahoma, and Oregon. And you can see that they're all very, very similar. And basically what happens in this acres per day, that you get above that 80th percentile, then it becomes an exponential function, basically. So this is where this 80th percentile idea came in. And so basically anything above that, we think is the space to be thinking about red flag territory, or potentially. Okay, and then in the next slide, we can show you that here in histogram form. So we've combined now all of these fires around the country, all statistics, and so we've got histograms for the 80th, 95th, 97th percentile, where the scoring has been applied that we showed in that earlier table. And basically it's a pretty big jump going from 10 to 11. And so based on this is where we're going to suggest that if you have a score of 11 or higher, this will be the place now to think as a guidance product that we want to be looking at in more detail about the potential for a red flag. And then in the next slide, this then is the final guidance product, the decision matrix. And basically in the top box, we've combined ERC with RH. Again, there's your percentile categories, and then there's your scores. And then in the lower box, we combine those two with the wind percentiles. And so we've color coded 11 and 12 is yellow, 13, 14, and 15 is red. Again, basically just saying if we get into that 11 and higher, 11 and 12 territory, we definitely want to be thinking about it. The 13, 14, and 15 is you're really getting up there in some pretty high percentiles. And by the time you get to a score of 15, you're really at the highest percentiles. And this might be a place to think about, are we now in particularly dangerous situation territory? Because if we're at the most extreme percentile, 99th or even 100th, it's a case that we haven't seen before, that might well suit that PDS. Okay, and then next, we did some testing comparison. Well, what would this matrix have looked like during 2020 in relation to what was issued? And basically, we found that there was a lot of, in 83% of the instances, the score of the RFW was greater than or equal to 3 in that 2020 event. And so we were also finding then there was some good correspondence to the actual red flag warnings that were issued, because that's going to be an obvious question. Just how different is this? Will it catch some things that right now the red flags do not? Hopefully it's not going to be completely different, and it turns out that it's not completely different. It's a refinement that provides this consistent methodology across the country. So in the next slide, we can take a look at a couple examples in map form. Patrick and team at Storm Prediction Center has been helping us a lot. And one of the things that they did was to be able to create these gridded maps of the matrix itself, along with the number of the outputs. And here's an example back in September of 2020, where you have the fire weather matrix, the decision matrix in colors there, with that bright purple being the highest value. And then the gray areas underneath are the officially issued red flag warnings from the respective WFOs across the West. This was a pretty active day, as it turns out, but you can also see a lot of correspondence between what was issued and what this decision matrix would have indicated as guidance for potential issuance. Now, one of the I think neat things about this is on a 2.5 kilometer grid. It's RTMA grid. Is that you can certainly pick out a lot more detail in this. And so you might ask, well, this is kind of interesting, because here's an area that actually is showing extreme percentiles here in north central Arizona. There wasn't an official red flag warning at the time. I don't know the details of that, but I think what this does highlight, and it's going to be one of our recommendations, that we think about issuing this type of information, a red flag type of information, maybe not on fire weather zones, but more on a polygon basis, like is done for other warnings or other warning products. And then the next slide is just one more example. Lightning for a few offices is considered a primary trigger to issue a red flag warning. So here's a case in 2021, July, where there's a red flag warning that's going to be strictly, as far as we can tell, strictly based on lightning, because I don't know, the winds, the RH, the ERC, all that was happening further east. And in fact, there were red flag warnings underneath this space as well. So here we get to see really two different types of red flag warning. One that seems to be based on the traditional, more traditional meteorology perspective, and then one that's just strictly based on lightning. What goes into that, I couldn't tell you off the top of my head. Maybe there's some attendees here that know the details of that. But this does come back and lead to, again, interesting discussion about the inclusion of lightning and even other factors, into a red flag. But for that decision matrix, we are proposing that the wind, the humidity, and the ERC be the primary factors that provide that initial guidance, again, to the potential issuance of a warning. So I think in the next slide, this now gets into some of the great work that Tamara has undertaken, discussing red flag questions and the topic with fire managers across the country. So Tamara, I'll turn it over to you.
Thank you, Tim. So one of the things that I did on this project was a survey. We had gathered a lot of anecdotal evidence that, how different practitioners in the fire management community used these products, but we wanted to do a little bit more of a robust sampling. So we did 2 data collection periods, as you can see there. Most of the responses were from federal and state agencies, and I would also add that we did have pretty good coverage across the U.S. We had responses from almost every area, every region of the U.S., but the predominant number of responses were from the Western United States. And I would say the Southeast was a little underrepresented. That second data collection period was actually an effort at oversampling to try and get more responses from the Southeast. No surprise, it was mostly male respondents. And the positions were largely described as, AMF, FMOs, AMFMOs, different like descriptors of fire staff, module leaders, crew bosses, things like that. So on the next slide, I just have a brief overview of the results. So we, anecdotally, we had been hearing 2 different things kind of across the time that we've been working on this issue, which was originally funded by the California, Nevada Applications Program, which is part of the RISA program out of NOAA. And originally we heard a lot that things were overissued. This is the first time we had actually tried to do a more robust sampling on people's perspective of that. And you can see most people actually feel that red flag warnings and fire weather watches are issued appropriately. When I dug in a little bit at that overissued area, I would say very broadly, it tends to go with people that have a lot of wind, that just generally are in windy, really windy places like the Reno forecast area, the Ely forecast area, parts of Arizona, some other like very plains kind of environments where it's just super windy. Then on the next slide, we asked some questions about how are people actually using these products, because there seem to be some differences on how our forecasting partners that we talked to thought that these products were used versus how fire management said that they were using them. And so you can see that they, from the fire management perspective, this is how these products are used for the most part. And they're used very strongly for resource allocation and firefighter safety, and also general public safety. But they're used across the board for a number of different decision-making actions, as we'll see in the next slide. One other thing that we did ask about in this, because we were a little, I don't know if suspicious or concerned is the right word, but we wanted to know, do people actually understand the differences between what are the criteria for issuing a red flag warning versus a fire weather watch? And so I think this is a pretty interesting finding. And again, this is not a representative sample. We had about 383 responses total. You know, clearly there's a lot more fire management personnel out there. But go ahead. It does, I am getting a bit of an echo. So is that bad on your side, Tim? Can you hear it?
There's no echo
Okay,
here.
then I'll ignore it. So I guess the thing to point out here is that there is quite a bit of conflation between the two products, and most importantly, it's the agreement on a fire weather watch is issued for less severe conditions. It is not issued for less severe conditions. So this misunderstanding, I think, is an important one for the National Weather Service to do more outreach and education on, in the future, and try and really alert the fire management community that, the severity it's not a difference in severity, it's really a difference in timing and those longer lead times. And you can see there is a number of people as well who don't understand about that longer lead time. And so if you want to go to the next slide, Larry. And then we asked some questions about how they used these products, and also very specifically, if we are kind of poking into that two-tier aspect of this. And so do they use them under different severity levels? So we asked people to tell us about what management actions they took when a red flag warning or fire weather watch was issued. And then we also asked if there were additional management actions that they took or decisions that they made if it was, exceptionally severe conditions. And I think what's interesting about this is that clearly these products are used in decision making, but there's not a whole lot of difference between the red flag warning and the fire weather watch in terms of how they are used. When you just generally kind of eyeball these two graphics, things look pretty similar. They're not that different. And the red flag warning is on the left-hand side of your screen, and the fire weather watch is on the right-hand side. And I think that is my last slide. It's just there's one more, sorry. As a little extra, we also asked about communication between the fire management practitioners that responded to this and the National Weather Service with their WFOs. And I think it very nicely says that overall, the fire management community feels very strongly and agrees with the statements that they are in contact with their WFOs and that they feel that they can contact them, which I think is a really great finding out of this and says a lot about the quality of relationships that the WFOs have built up, over the last decade. And that is my last slide.
Okay, thanks, Tamara. So the next set of slides are going to be very wordy, but you will get to see these in the final project report that we're working on right now and anticipating being able to go public with it sometime in November. But now that you've seen, the background and some of the things that went into it, then we spent some time thinking about recommendations based on the results so far. And so the first of these is, yes, it makes sense to use a nationally consistent methodology across the country. That energy release component from NFDRS should be used because that handles the fuels part. We strongly think that utilizing historical percentiles is the way to go, because this allows for common comparison across all the zones, and it also highlights the more extreme conditions. We recommend, from the matrix, that days exceeding a score of 11 or higher. And if you get into that really highest area, that 99th through 100th percentile, this might be a candidate for PDS. Now, one of the issues is we've got to come up with numerical percentile values, historical ones, and then this also has to be made in an operational environment. So at present, yeah, RH and the wind speed is easy, but the ERC not so much at the moment, and so there needs to be an effort to get an operational ERC in place. And so this is something that the Weather Service and the Forest Service can and should coordinate for that product. We think that the decision matrix itself, I mean, this should be implemented on the NDFE grid. That makes the most sense because that's the operational environment and that's readily accessible to everyone. And then the next slide. So this bit about lightning, and there's a lot of really interesting discussion. We've heard both ends of the spectrum on this, but it is fair to say at the moment there is no standardized national methodology for determining when lightning should be included as part of an RFW. So if it's important to have the standardization, then this needs to be looked into further. We think it makes plenty of sense to include lightning in an RFW decision and discussion, but perhaps at the moment not the primary factor for an issuance. Now, having said that, here in the second bullet, fire management has expressed a need to know if dry and abundant lightning will be a concern. So this is a requested product. So the recommendation would be to undertake further exploration. And there's different ways here to think about it. Should there be a lightning specific RFW? Because for some regions this has been the case. We saw one of those in one of our examples. And to do the development, if we're going to go down this path, the development of some type of national consistent guidance product, if it's lightning is going to be used as a factor in the issuance, or could it be that just headline messaging alone would be sufficient to depict the lightning concerns? So one possible way to explore this further is take a matrix approach, not unlike what we've done so far for the red flag, and where you could combine factors such as lightning currents and probability of ignition, and there might be other factors to look at as well. And then there's the question of, we said early on there's 524 different versions. Now, a lot of those are just going to be minor adjustments to some number or whatever, depending on the fire weather zone of interest. But if any local office does add any factor, to the primary decision matrix, then these should be justified right through science or SME statements or regulatory needs. So try and encourage a little more background work into those efforts. When issuing an RFW, it's always great if the meteorological cause but also we're finding that an indication of associated uncertainty and forecaster confidence plays a really important role as well, as opposed to just well, here's your warning. And then I think I mentioned this before, but when we go back and look at those gridded maps, to us it just makes sense that maybe we should really be thinking about polygon type boundaries for issuances, And that way we can, minimize areas that may not be as impacted as much, and highlight areas that might be impacted in an even more extreme way, like we saw with that one very high percentile in Arizona. All right, and then next slide. We think it'd be helpful if descriptive information regarding the historical and seasonal severity was included. Just some little statement. The fire agencies use this thing called pocket cards that tells you things about a historical fire in a particular area. And one of the interesting things and good things about that is it will provide some historical perspective. So to make sure that's included could always be very beneficial. Tamara, this next set came from your work. Do you want to go through this?
Yeah, I just think, I'm not going to read all of these, but I do think that the results showed that there, in terms of decision-making support, that a two-tiered product has a lot of value, because under those exceptional, exceptionally dangerous situations, when respondents in the survey felt that conditions were exceptionally severe, they did take additional steps and made additional management decisions. And so I think these products are really important, not just for firefighter safety and general public safety, but they're also very heavily used in terms of resource allocation and decision making. And then I think it's also important that we keep things in context of hazard simplification and keep that continuity across products, particularly as this is often more a public product now, as well as a product used by a sophisticated user group like the fire management community. As the general public becomes more aware of these products and that two-tier system, I think it'll be really important to keep that continuity across all of these products, warning and watch products. And then, as I said earlier, I think doing some additional outreach and education about the differences between, that there is no difference in severity between a fire weather watch and a red flag warning would be a really important thing to do.
Okay, thanks, Tamara. And let's see, what's on the next slide? I don't remember if we had one more. Yeah, just a couple more, I think, that were tied to your work, Tamara.
I just think it's always really helpful if you're, this is kind of a mixed product in that it has, application for, management and decision support, but it's also used very broadly by the general public. And so those plain language headlines, I think, are really important in clarifying that message to the general public and how they may use it to make decisions. And how they may approach things in their daily lives that day, whether that's from making a decision to not engage in some outdoor activities where sparks might potentially happen, to making sure that their go bags are ready in case there is a start if they live in a very wildfire-prone area. I think those are all good things to think about in future updates for this product.
Okay, thanks. All right, and then our very last slide, what next? Patrick mentioned that we have now an effort that is just beginning from those DSRA funds. And so we're going into the next phase here of assessment, validation, evaluation. And so there'll be things like refinement of the matrix. We want to do some more detailed comparison with existing issuances. We definitely want to do some testing and evaluating the matrix with WFOs. And so this will be a real opportunity to get feedback from the field and see how this might work, in an how the matrix might work in an operational environment. Want to look further into the potential utilization for these highest percentiles in relation to the PDS forecasts. A usability assessment of the matrix matrix itself by the WFOs. And then, of course, developing a verification process. And Patrick mentioned that there's another project underway that will help look at that particular issue. So with that, I think that's our summary of the work so far, the story so far. Larry, back to you.
Okay, thanks, Tim. Appreciate that. I'm going to open it up to questions here. We do have one. Let's see if I can get it up here. Where's the question? There it is, questions. So let's do this so it's make it easier for me to read. All right, so Connie, and sorry if I mangled your name, Connie Claystrom says, hi, excellent work. Related to the question of RFW for thunderstorms, these often bring gusty winds beyond the predicted surface winds, which contributes to spread as well as safety and resource issues for initial attack. Also, lightning from thunderstorms can lead to concerns from holdover fires. Are these issues also incorporated in your work?
Not to date. They are not. And so some of this may come up in the next phase, but this just may wind up also being future work. As we said in one of those recommendations, there is a recognition that lightning, it's obviously well known that lightning is a safety factor. But then it's also a question of what role should lightning play in terms of an actual RFW?
Okay, next question from
answer for that.
Thanks, Tim.
Sorry, go ahead, Larry. Yeah, sorry, go ahead, Larry.
The next question is from Travis Vertigan. It says, what NFDRS fuel model did you use for ERC?
Well, at the time it was G, and under version 4, it'll be Y. There's been plenty of studies that showed that you can incorporate one model like that for this type of climatological work. Now, it could be that we might want to look at a little more detail, say if we get into the high plains, more of the grassland regions, where you have very flashy fuels and fast-moving fuels and wind. We may need to do a little bit something different there, but that's something that can be looked at under this phase that's just starting up now. When I said there would be some refinement work to the matrix.
Okay. Darren Claybo asks, are the ERC percentiles calculated on an annual basis?
No, they were calculated on a daily basis. We used actually the data out of GridMet, which is a 4-kilometer grid, to come up with those initial ERC percentiles. There's a data set that's being looked at that actually the NWS Modeling Center produced, and that's related to RTMA. It's IRMA, the unrestricted mesoscale analysis. This is on a 2.5-kilometer grid, and there's an effort underway to get that grid in shape in a way that then historical fire danger calculations can be done on that. And the data set itself will go back to 1985. So it's a pretty long period, 2.5-kilometer data set. And when that's available, then some further refinement can be done on fine scale resolution. In the meantime, we had to downscale the 4 kilometer to the 2.5 grid.
Okay, thank you. Eric Wise asks, maybe I missed it, but how would this approach impact the number of RFWs issued? Seems the survey results lean toward overissuance with current practice.
Yeah, well, we don't know yet. I mean, that's going to be part of the testing and the evaluation here in this next phase. SPC has been running the matrix now for a couple of years, and so we have a data set. And also, they did a little bit of historical runs with it. So we'll probably have 3 or 4 years now that we can look at to compare what an issuance would look like strictly from the matrix versus what was issued, and get a better sense of how those two are going to align and what that might mean for under or over issuance.
Yeah, and I think too, the vast majority, not the vast, but the majority of people very strongly there is a clear signal that most people felt these products were issued appropriately. But I think the opportunity here is, now that we have those kind of known areas where people felt they were overissued, then we can pay particular attention to that during this testing phase and see if the new product would have an impact on that perception of overissuance.
Okay, Andy Chiupi asked, how are the ERC and KBDI related? I believe KBDI accounts for ERC. I ask this as our partners are mainly asking for KBDI values for decisions in our area.
Well, that's interesting because I didn't think KBDI was all that effective in the West since it was developed for the soil types in the Southeast. I know that there's some work being done actually under the National Integrated Drought Information System to make KBDI more functional for the West. I'm not sure exactly, what the status of that is. But of course, KBDI is a drought indicator. It's an underlying factor for the fuels, but it's not a driver. So we've just been focused on the drivers, which will be the meteorology part, including the ERC, which effectively is a meteorology part.
Okay. Brian Bargenbruch asks, thank you for this presentation regarding the matrix. It appears that the analysis is rooted in probability of detection for significant fire spread. I am curious if there has been any analysis of relative false alarm rate area compared to other methods.
No, I'm not sure if I understand the question fully. So yeah, to come up with the percentiles, there was, fire on the ground itself. I mean, that's how we know what the daily rate of spread was. But this matrix itself doesn't have anything to do with whether or not there is an ignition. It's the potential conditions of rapid fire spread if there is fire on the ground, or if there were to be an ignition. So to me, that's a different forecast problem, different forecast question.
Okay. Travis Vertigan asks, can you expand further on calculating percentiles on a daily basis?
Right. Well, we had like 30 or 40 years, I think, available in that GridMet data set. And So, so basically, yeah, you'd wind up with a sample size of, say 40 per day to do that if you combine all the years and look at it daily. Now, you may not have to look at it daily, and we might tinker with this a bit more. But definitely it needs to be some finer resolution, not annual values. And I'm not even sure that monthly might be okay, but I worry a little bit about the transition periods because just a couple of weeks, you can have some pretty rapid transitions, weather and climate.
Okay. Just as a point, we are at about 1 hour, but I think this is important enough, and there's some good questions being asked that we're gonna, if it's okay with everybody, we're gonna continue for a little bit. Luckily, we're not paying YouTube by the hour, so here we go. Tom Bird says, it would be great to see you analyze a day like the huge growth day, April 22nd, 38,000 plus acres on the Hermit's Peak fire in New Mexico this year, when Albuquerque and the IMETs were messaging the day as a historical day, to see if it lands on a 14 or 15 in the matrix.
Yeah, I agreed. And I think that's something that we can do is take some of these special big events, and just see how different they might look. So I like that.
Okay. Scott Stearns says, have you thought about looking at work from the HDW index? It seems that we're missing the mark on the importance of true, not temperature related, relative dryness. There's been some research showing fuel moisture flux having a much closer correlation to vapor pressure deficit than relative humidity.
Yes. Yeah, I agree with that. The hot, dry, you're referring to the hot, dry, windy index. I suppose that's something we could potentially look at. Vapor pressure deficit, of course, is currently not a well-established operational product, I don't think. I don't know, is that something that you can easily find off the RTMA grid and AWIPS? In other words, yeah, the point is well taken, and that might very well be true, but we also have to focus on, I think, what is operational readily available. Okay. Unless somebody wants to propose something like VPD become an operational product.
Okay. Just as a update, Andy, who asked about the KBDI, says, I am located in the southeast. So that's where that was coming from.
Oh, okay.
Connie writes again, says, it might be interesting to differentiate between whether red flag warnings for low RH and wind versus thunderstorms are overissued. Lightning red flag warnings may have more air with them, especially for dry thunderstorms, which are more challenging to forecast.
Yes. I've also been involved in a bit of work in Victoria, Australia, related to the Black Summer fires, and it's pretty clear that there were some upper atmosphere things going on there that was a major driver with those fires. That's not to say that the red flag, if we'd had a red flag, for there, I'm sure it would have been issued, but it is more complex, right? There are other things going on. So it's a valid question, I guess. Again, are there some other factors that would be related, to safety, extreme fire spread, extreme fire behavior? Maybe something to look at down the road.
Well, and I think there's opportunities to do that in the next phase of the project when we're working with the WFOs to kind of to see how the usability analysis, and particularly in the areas that we've identified that there's a perception of overissuance. We could add a subset of questions into that analysis to help pull that apart a little bit more effectively. I think it's a really good suggestion.
Mm-hmm.
Okay, Kevin Osborne says, just points out KBI is one of the initializing inputs into fuel moisture and NFDRS, and thus one of the indirect inputs to generate ERC. Travis Vertigan says, nice work. Fire community is more familiar with an annual percentile. Marshall Fire in Colorado would be a good one as an exceptional event. In this case, ERC were high for that time of year.
Mm-hmm. Okay.
Tom Bird says, wait a minute. I probably missed this, and maybe it's not important, but I wonder how the total score numbers came to be 1 to 15.
Basically, because we divided up the percentiles into six categories, scoring from 0 to 5. And so you have, so 5 is the max score, and you have 3 variables. And so if all 3 variables were in their most upper percentile group, then that would be 3 times 5 to get 15.
Okay. Tom says, excellent. All right. That's the last of the questions on here, and given the time, I think we'll go ahead and wrap this up. Tim and Tamara, thank you very much for your work on this. We really appreciate it. We're looking forward to where this leads, and hopefully whittle down the 524, maybe down closer to 500. So we got high hopes there. Again, thank you much. And with that, we are going to wrap this up.
Yep, thank you, Larry, and thanks everyone for attending.
Thank you.
This concludes today's episode of Fire on the Fives. You can catch this episode or any of the Fire on the Fives episodes on YouTube by searching for NWS Fire Fives. This webinar is a presentation of the Fire Weather Program of the National Weather Service.
All right.